Welcome to This Explainer. Today, we're diving into what is arguably the ultimate cosmic mystery. Why does our experience of time always seem to march in a single, irreversible direction? We're going to look closely at the very fabric of reality itself.
Think about it for a second. Why can we vividly remember yesterday, but we can never remember tomorrow? It's kind of a profound paradox, right? We can recall the past perfectly, yet the future is entirely hidden from our perception. Why does time feel like this strict, one-way street?
Or consider a completely ordinary event. You drop a glass and it shatters into a chaotic mess on the floor. But why does it never spontaneously rebuild itself? We literally never see those shattered pieces just jump back together to form a perfect cup. The events of our world unfold in a highly specific, one-way sequence.
This undeniable one-way sequence of events, that's what physicists call the arrow of time. It's the concept that separates our psychological experience of past, present, and future from the cold underlying mathematics of the cosmos. It's not just some feeling we have, it is an objective, observable directionality in how the physical states of our universe actually evolve.
Section 1. What is time? Let's quickly define the dimension.
Before we can figure out time's direction, what do modern physicists actually mean by time? Well, Albert Einstein had a simple yet incredibly profound operational definition. Instead of relying on abstract human intuition, he recognized that our universe is filled with periodic, measurable processes, like the swing of a pendulum. To Einstein, physical time is quite simply what we measure with those clocks.
Now, our everyday experience makes time feel like a single, universal clock ticking identically for everyone, everywhere. But relativity completely shatters that illusion. Relativity revealed that time is actually a flexible dimension. It is totally dependent on your speed, your vantage point, and even gravity. So time isn't just a rigid backdrop, it bends and stretches.
Section 2. The arrow of entropy.
So, to find the root of our one-way experience, we have to look at thermodynamics. Across the observable cosmos, we see a statistical tendency for things to move from order to disorder. Ice melting into a puddle, perfume spreading outward through a room, heat moving from a hot iron bar to a cold one, or flowing from our sun out into the cold depths of space. Things naturally randomize.
This irreversible rise in disorder is famously known as the second law of thermodynamics. It accurately describes why the physical states of our universe evolve asymmetrically. In an isolated system, entropy, or disorder, has a statistical tendency to spontaneously increase. That gives a solid, quantitative description to our arrow of time.
Section 3. The Great Symmetry Puzzle.
But here is where our detective story hits a massive, mind-bending contradiction. We have a deep paradox on our hands. While our daily lives, and those breaking glasses, are governed by the one-way street of entropy, almost all the fundamental laws of physics are mathematically time-symmetric. That means the equations describing the most basic elements of reality work perfectly well whether time is moving forward or backward.
This actually builds into a grand proven concept in physics known as the CPT theorem. It tells us that if you mathematically reverse the direction of time, swapped all matter for antimatter, and flipped space like a mirror, the physical laws would behave exactly the same. The deepest equations of reality just do not seem to care which way time flows. Section 4. Relativity and human memory. So, if the deepest fundamental equations don't care about time's direction, why do human brains perceive this strict chronological flow? Well, relativity shows us that space and time form a combined four-dimensional geometry called spacetime. In this spacetime, different observers moving relative to one another can actually disagree on the order of distant events. There simply isn't a uniquely correct answer to what is happening right now everywhere in the universe.
Furthermore, because of time dilation, a speeding clock will actually mathematically dilate or run slower compared to a stationary one. Time is relative to the observer. It proves time is not absolute. It shifts based on gravity and motion. This definitely doesn't mean time is just an illusion, but it does mean it's incredibly flexible.
This brings us to how our biology fits into all of this. Scientists propose that alongside the physical arrows of thermodynamics and cosmology, there is a distinct psychological arrow. Research in neuroscience suggests this is dictated by how our brains record memories. We remember the past because our brains literally encode new information in a specific sequence as entropy increases around us. So our perception of time passing is deeply tied to how information is processed.
Section 5.
The early universe.
Since the fundamental laws are mostly time-symmetric, and human psychology is just biology, we have to look to the largest scales of the universe to find time's true origin. The ultimate explanation lies in cosmology. We trace the timeline of our universe all the way back to the Big Bang, 13.8 billion years ago. You see, for entropy to continually increase today, the universe absolutely must have started in an exceptionally, almost unbelievably low entropy initial condition.
Now, there is a subtle but critical distinction here. It turns out that while the early universe's matter and radiation were actually near maximum entropy, a hot, dense state of thermal equilibrium, its gravitational field was highly ordered. This smooth, incredibly low-entropy gravitational state essentially wound up the cosmic clock, setting the necessary stage for entropy to relentlessly increase as cosmic structures grew over billions of years.
Section 6. The biggest unsolved question.
But establishing this cosmological starting point doesn't fully close the case. It just pushes the mystery one step further back. We have to ask, why was the universe born in this incredibly specific, low gravitational entropy state to begin with? While theories like cosmic inflation attempt to explain the smooth initial setup, inflation itself requires special initial conditions. So scientists are still actively investigating the ultimate cause of how this all started.
And that leaves us standing right at the very edge of modern physics. We know as a scientific fact that entropy increases. We know relativity is very real. But we are still searching to answer this. Is the arrow of time a fundamental ground floor property of nature? Or does it merely emerge from statistical physics and the specific initial conditions of our universe's birth?
Time is this rigidly measured reality that dictates every physical state of our existence. Yet, as the saying goes, perhaps the strangest thing about time is not that it moves forward, but that we still don't completely understand why there is a forward direction at all. Its deepest mechanical secrets remain partially hidden in the fiery origins of the cosmos.
As we continue to probe the depths of space-time, relativity, and quantum fields, we are left to ponder this ultimate, unanswered question about the fabric of our reality. Is the arrow of time written into the laws of nature, or is it a consequence of how our universe began? Thank you so much for joining me for this explainer, and I hope this leaves you looking at the clock on your wall with just a little more wonder.